So now we catch up that usage of theoretical distributions is a very powerful approach, and more to say, really an approach which is widely utilized. Now we are moving to the next section, which is understanding probability distributions. And we are starting with one of the most known distributions. It's a normal distribution. So first of all, it should be stated that a normal distribution is defined by two parameters, the mean and a variance. A normal distribution is often used in simulation for variables like processing times or demand, when values can vary around an average and extreme values are not very common. However, a limitation is that it can generate negative values, which is unrealistic for most time-based variables. So, to explore how actually the parameters mean and variance are impacting the normal distribution, I would recommend you to see a software which is called StatFit and explore how changing the parameters affect the shape of the distribution. A StatFit simulation software is available in our course. The next very popular distribution is exponential distribution. As you are able to recognize, exponential distribution is defined by two parameters, which is shift and rate. So just a short comment, most probably if you are familiar with exponential distribution, you catch up that usually only one parameter, rate, is indicated. Exponential distribution is commonly used in simulation for inter-arrival times and waiting times. Short times are most frequent and the probability decreases as time increases. This one is a physical meaning of the curve which you are able to see right now. The mean equal 1 over lambda and the variance equal 1 over lambda squared. It's how we are calculating mean and variance if rate is known. A limitation of the exponential distribution is the following. It assumes a constant arrival rate, so it doesn't model peak and off-peak periods well. A shift can be used to define a realistic minimum time, for example, service time of at least 2 minutes. Uniform distribution is defined by two parameters: minimum value, usually marked as A, and maximum value, usually indicated as B. All values inside the interval are equally likely. It's often used for manual task duration, arrivals within a fixed time window, or demand that varies within known limits. The means is the average of A and B, and a variance depends on the width of the interval. However, the uniform distribution can oversimplify reality, because real systems rarely have perfectly equal probabilities. The log-normal distribution is defined by two parameters, the mean and standard deviation of the logarithm. So it's commonly used for service times, repair durations, and delivery times, where most values are short, but with a specific small probability we could get a very long cases. The following distribution is always positive. It's something what should be stated and which is important. So, because of rare but extreme values, it can significantly affect system performance and must be used carefully in a simulation. So far, we focused mainly on continuous distributions, such as time and distance. But beside of continuous distributions, we also have discrete distributions. So discrete distributions are used when values are counts or events. For example, the number of arrivals per hour, which is integer of course, the number of defects in a batch, or the number of calls before a failure. So, common discrete distributions used in a simulation include binomial, Poisson, geometric, and discrete uniform. We are not going to explore the mentioned distributions, but again I would like to pay your attention that here are indicated the links. So if you would like to go deeper inside and catch up what is the nature of the mentioned discrete distributions, so just click on it and enjoy.